This conference will now be recorded.
So basically, today's agenda will be to go through the module one, like starting with the module one, where we see the architecture. We will start off with the architecture. That will be the good way to say that. And then we will also see how we set up our first setup, environmental setup for Oracle, which is yeah, like how you set up your environment, even the DB and like how you do that. So those details we will see today, right? Like how you do and you like how the interface looks like and all like a crash sort of thing I will be showing. All these things we will go in little detail uh, when in our real sessions. Okay, when we start. Since this is a demo session, so I will be running through few things because so that you get an idea and even you get like you can carry a lot of summaries from the demo itself, right? Like so in that way I will be doing it. So yeah, so we'll start in 2 minutes. So I had shared the queries sheet, so all of you can update it with the queries if at all you have any. So that what generally I do it, I go through those query sheet just a day before and we cover it, okay, in the upcoming sessions.
So how many days this course will be, length of the course?
Rohit, so total the length of the course will be around 20 hours, which is 20 working days.
20 working days. Okay.
Yeah. Okay, so let's start. So let me share my screen. Uh, right. So yesterday we were seeing module one. We had started off with it. So today we will continue from there. So when we say like when we discuss about SQL architecture and its salient features, right? First of all, whenever you have a DB, so inside the DB, every data is stored in something called blocks. So blocks are nothing but like they're like a fundamental unit inside a DB. Okay, so you can consider it like bits and bytes, then MB, KB, we say, right? Similarly, uh, the smallest unit in a DB, or like we can say one small entry inside the DB, it's a block. Okay, so a block can have 2 KB to 32 KB size based on what is set actually. So this you can actually set inside the DB like what your block size is. It can be by default, it's generally by default 8 KB, which you can make from 2 to 32 KB. So just assume in such a way that a block is the most smallest or the fundamental unit of a database storage. Okay. Now this we will discuss about this block in further sessions. Okay. Currently, just assume like block is the most fundamental unit inside a DB. Now, when you speak about the DB architecture, right? So let's discuss about that first. So this one we are seeing for the Oracle DB, okay? And then we will come back to MySQL also. Okay. So generally we have, when we speak about the DB architecture, right? So we can divide it into main components. Okay. First is the user process. This is the place where where any SQL, or we can say anything, enters into the DB, or the first layer, we can say the client layer. Okay. Then you have the server layer starting, which starts with the server process, and then you have the PGA, or we call it private SQL area, or private. So we will discuss about that. Then we have the PGA. Then we have something called the SGA, and this is basically the disk. Okay. So see, whenever a data or a query is executed, that execution can happen in two ways. One, it can pick up the data from the cache, which is here, like the buffer cache we call it, or it can pick up the data from the disk. Now, when do you think the data will be picked up from the disk? Any guesses?
First time
Yeah. So
without care.
generally, a query, when it is executed for the first time, right? Where you don't have any, like even the Oracle doesn't have any idea of what the data will be and all before. So for the first time when that happens, that query or the data will be pulled up from the disk. Now, once that is done, it will get stored inside your buffer cache. Okay, through some other, through some various methods, because buffer cache is not the only cache which we have. We have library cache, we have result cache, dictionary cache. We will discuss all this, okay, what these caches are. But anyways, so this first time what that happens, we call it with a specific word called hard pass. So see, generally, when a query is executed for the first time, and if it happens from the disk, we call it a hard parse. Okay, and the one which comes from the cache, or it's coming from the SGA, right? So we call it the soft parse. Now, as a performance concerned, what do you think? Should the hard parse be high or the soft parse?
Of course,
Yes, soft parse should be high. Then only the system performance will be high. Because now the reason is simple. Generally, cache access will be faster than the disk. All of you agree with that? So the way the cache is accessed, right, it will be faster most of the time compared to the disk, right? Getting all of you? Any doubts in that? So see, now whenever you access something from the cache, it is more 99% fast, most of the time faster than the disk. What I pull from the disk. Is that part clear? Am I audible?
Vishnu. Yeah.
yes, yes. Hello.
Yeah. Yeah. Yeah.
Yeah.
Okay. So that's where the hard part, soft pass comes into picture. Now, this is very important as per performance is concerned. Okay. Ultimately, there are few things which, as a performance engineer, you will focus. And one out of that is this important point. What you will do is reducing the hard passes. So generally, how you reduce the hard parses is very important, because more the hard parses that happen, more your query performance will degrade. Okay. Now, these hard parses generally will happen when there is something new, right? Either the query is executed for the first time, or some data is not found in the cache. Okay. So to avoid these things, so certain amount of algorithms or certain amount of querying, and even the cache also, right? Whichever is there, that cache also it's not that you store everything in the cache. So there is a clearing also that happens frequently inside cache, more sort of like a garbage collection or clearance, right? So this clearing configurations are also very important when it comes to the caching or the hard parses count and all. And generally, this is the starting point of any analysis. Okay, before we go in depth into whether my query is performing well or not, whether what I have written properly, the SQL statements are correct or not, we start with these initial things like the hard parses to soft parses, how many disk reads are happening, like how much the cache was executed, how's my how cursor sharing happening, right? So all those things. So for that, first of all, we need to understand the architecture, right? Now inside the SGA, let's go to our PPT. So let's speak about the PGA. Okay, we call it the Program Global Area. Okay, so PGAs are nothing but, in PGA further it is divided into session area, or persistent area, okay, or runtime area, cursors area, and the SQL work area. Okay, so basically what happens in the PGA is, all sort of like the sorting of the query, or like if you have something like storing the bind variables. Now all these things are, we will go in detail, okay, in the upcoming sessions. But for now, just remember, PGAs are basically the entry point, or where the, it's more sort of where the classes in code, right? Whenever you have a code execution happens, right? In, like, let's say Java or something, where the classes are stored, or we can say the place where the objects are created, right? So this PGA is more sort of that. Okay, it will store those entry level variables like the session variable, because after PGA, the SGA is a common thing, but PGA is user specific. Is that part clear? So PGA, what happens is, when the memory is allocated inside the PGA, or like when an address or like a space is allocated inside the PGA, it is user specific or session specific, more specifically to say. But inside SGA, it is not session specific. It's like a global thing. Okay, or whatever processing should happen, it will happen inside SGA, and it will come back. And whatever processing happens, where is the source of that processing, or from, for what that processing is happening, will then be mapped by the PGA, because whatever session variable etc is there, that will be stored in the PGA. Getting my point, all of you? What's the PGA? Any doubts?
Uh, Vishnu, one question here, that
Yeah.
how is PGA important in terms of DB tuning? Like
Mhm.
what you said about hard parse and soft parse, right? So
Mhm.
soft parsing and how PGAs will actually be related.
Yeah, so that's where we are coming into, right? So PGAs are the entry point where your query, as soon as it enters the DB, right? Or I can say when the process starts in the DB, it will hit the PGA first. Okay, so in case, now it's not about the hard parse. In case, if your space is less, okay, like let's say 100 connections is what the limits I have, okay, and already the PGA whatever was there, that space is allocated, it's full. Can new connections be created? What do you think?
No, it can't be.
We cannot, right? So that's where the PGA comes into picture. So it will actually define or decide how many user sessions I can create at the same time, parallelly. Clear, all of you? Getting my point? Any doubts in PGA? Just call it out.
But if your
Mhm.
cache is already full and how many number of sessions have been created and defined by PGA, like what is the essence? Sorry, I couldn't connect that point.
Yeah, okay. So see, now the PGA is actually, they store the session variable, login information, session status, etc. for each user, right? Okay, and even the cursor area, it stores the information of the cursors. Now if your PGA is full, right, it cannot store the new ones which are coming, so it will not enter your DB itself, it will be in a waiting state.
Got it. So here you can increase or decrease. So this is where fine tuning will come in, is it?
Correct. Yes. So you can
Okay.
increase, like let's say if you're seeing, okay, when you're reading your report and you're seeing your PGA area, PGA size is low, or like your PGA size is almost hitting 100% most of the time. So there is either requirement of maybe reducing some the variables what is getting stored in the PGA, like the bind variables and all, or otherwise what you have to do is you have to increase your PGA size so that it can accommodate more connections.
Got it.
Clear, all of you? Any doubts?
Nothing from my end.
Yeah. Okay. So, so PGS play a vital role in that sense. Okay, so if your PGA resource is not enough so that it can take up new connections or new resource allocations, it will create a bottleneck. So how many ever users you increase, they will all come into waiting state. Okay, the query itself will not enter into processing state because it's not crossing the PGA itself. Clear? Okay. Now, what we will do before we jump into further, right? Let's set up our environment also, then so that you will be able to correlate things in that way. So let's go there.
Like, hello. Hello.
Yeah,
Vishnu, actually,
yeah, Aditya.
currently we are using proxy SQL in MySQL
Aditya, your voice
environment.
is low.
You can able to hear me now?
Yeah, yeah. Now it's audible. Yeah,
So, actually, to overcome the DB problem, like
mhm,
to by increasing the number of active connections and all, so we use
yeah.
the proxy SQL. So, how the proxy SQL helps into that? Like, I wanted to understand that.
Can you repeat your question? Like somewhere I missed that last line.
So, actually, to reduce the number of active connections, so
Yeah.
as the active connection might be the bottleneck in the DB performance, right?
Mhm.
So, to reduce the number of active connections, we have used the proxy SQL. So I wanted to understand like how proxy SQL works here.
Yeah, so that's a different thing altogether. But let's say now, if you want to understand how the PGS, for example, let me take some cases, okay? Like let's say, because if I go to those things now, it will be little high jump. Okay, we will see that in the upcoming sessions. But to give a clear understanding how the bottlenecks happen in PGA, right? Simple. Now, let's say, as I said, obviously there is something called a PGA memory, right? Generally we set PGA memories, and if the PGA memory is insufficient, that what will happen is most of the data, if you see clearly in this diagram, right, there are two things that will happen. Either your like whatever the connections which are happening, they will be in waiting state. Otherwise, what will happen is this diagram. Are you seeing this red color arrow
Yes.
here, where we are reading directly from the disk?
Yes.
Right? So what will happen is, see inside PGA there are different like sorting, then hashing, and all those operations also happen inside PGA, right? So what will happen is, now since I don't have space to do those things, what my PGA will do is it will directly pick the data from the disk. That means it will not even enter the SGA and see whether the data is available in the cache, or even the sorting or any hashing operations also it will not do. Okay, what it will do is it will directly pick the data like a hard parse, and it will try to deliver it if it's just a get operation. If it's a, we call it a data manipulation of yeah, go ahead. Okay, so next is, now this is one scenario where our PGA memory is not enough. Okay, but what are the other reasons why the PGA memory will increase, right? That might be a question coming into your mind. Like, is it always the active sessions, or there are some ways that I can reduce the usage, right? Yes, we can reduce. Okay, so wherever some operations like sort happens, right? Some frequent sort operations that happens, again it will increase the utilization of PGA. So if you can reduce the sort operation, right? Like let's say you have a query and you are sorting something before you get something or before you operate on something. If you can reduce that sort operation or some operations like sort, which we will go through, even hash join operations, sort operations. So these operations actually affect your PGA a lot. Are you getting my point? Aditya, Dev,
Yeah.
right? So in this way, now what you said is, I guess you said proxy, right? Aditya?
Yeah. Proxy SQL.
Yeah. So proxy SQL is a different thing. Okay, like basically why we use that is to give you a high level way. I will not go through very detail, but generally we use it in MySQL and MariaDB sort of DB. So what it basically it's called there you have query routing, load balancing, then such concepts. Okay, even query caching. Okay, ultimately it is about distributing the load. Just assume in that way. When you have some issues like this where your PGA resource is hitting high level, right, you can route it to different server itself.
Yeah. Okay. So, but proxy SQL don't have any impact on.
Your voice again,
So
yeah.
proxy SQL don't have any impact on active connections, right? Or it,
No, 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 it will not have any impact. Only thing is again the connection limits will be there. Okay, for this proxy SQL, like whatever routing or
Mhm.
load balancer setup they are doing, right, they will have a
Yeah.
connection limits, or we can say how much they throttle it down and all, right? So those will affect,
yeah,
obviously.
actually, yeah, we can redirect to the some of the queries to secondary server, and it automatically active connections automatically get reduced. So
Correct.
with
Yeah.
the help of
Yes.
redirection. Okay.
Yeah. Okay, so and generally when it comes to proxy SQL, right, but the bottlenecks what you generally see is maybe CPU memory usage, okay, getting high, and even connection management, which I said. So more number of connection, there will be some connection limits and all which they would have said. Even some caching issues which you might see, because generally the proxy SQL works more on the caching side, right? It will route the queries and also caching issues. Yeah, so generally, your bottlenecks will revolve around those when it comes to proxy SQL.
Okay.
Yeah. Okay. So clear all of you. What's see now when I say sorting, hash, and all, right? So those are the processes which happen inside your PGA. See, sort area, hash join, bitmap merge, bitmap create. So you should look for in your query, in your SQL, what you are calling. Do you have any of these such operations, sorting it, or the hash join, or bitmap merge, or bitmap create? If you have this, then you have an option to optimize your query also for your PGA, not just increasing the PGA directly, right? You can optimize your query also, even you can optimize your execution plan, which we will see. Like what is this called? What is this execution plan or explain plan? So when see in a high level way, for every query, okay, let's assume in this way. Let's say I want to go from as I said, some let's say Pune to Mumbai. Okay, I'm traveling from Pune to Mumbai. Now I can go to Mumbai through maybe NH48, which is one route. Okay, through expressway, which is another route. Okay. Now when you're executing a query, right? What do you think? Even execution of a query can also have multiple routes, which my DB can take for a single query. Am I getting making sense? So see, let's say I have a query where I am sorting the query first, okay, and then I am searching. Okay, now the same thing. What I will do, what I will do is I will not I will search the maybe no, not this way. Like let's say I have a table. Okay, first let's say I want to find what is there in the 10th row in front of the name Aditya. Okay, I want to search that. Okay, let's say what's the attendance count of Aditya in the attendance column from the employee table. Okay, now if I want to do, so what I will do, I will search Aditya's name and I will get the uh, what I can say, I will get the data, employee data, I meant like the salary from the column. Okay, now what I think is, okay, to improve the performance, what I will do is, since Aditya's name is starting with A, I will sort my table uh, alphabetically. Okay, then I will search for Aditya, because in that way, if you less intensive compared to search, right? Sorting is easier compared to search. So rather than searching all the rows one by one, I will sort it first. and then I will search starting from first row, because A will at least come in the top whatever, like how many top rows it will come, right? So the search will be faster. So now the same thing, the same result I can achieve through two different ways, right? Now this is, you can clearly understand, okay, this is what is happening. Now Oracle also has a little bit of intelligence in doing this. Okay, so when you write a query, Oracle actually decides, okay, how to tackle that query, like whether I should search first, whether I should sort first, whether I should search for the indexes first, whether should I join the tables first, right? So these level of understanding Oracle, the DB has, right? And from its understanding, it will look for a optimum method through which that query can be executed. Okay, so there is one way and second way. Okay, the second way, actually what it finds is, okay, the utilization of CPU, utilization of memory, utilization of different other things are less. So what it will do is, it will say, okay, the second method is what we will use to execute this query, and this thing it will store inside the SGA. Okay, so whenever that query will come, it will execute in that order what it planned. And that order which it planned, right, it's called the execution plan. And we also have something called explain plan that I will explain. But anyways, so are you getting what's an execution plan in a high level way when I say execution plan? Okay. Anyway, so I don't want to confuse you more with lot of theory in today itself. What we will do, we'll straight away go and set up our DB and let's see something in action. Okay. So first of all, you need to install VirtualBox, which you can easily install from online. Just
Yeah,
search for
quick question.
VirtualBox. Yeah, good.
Yeah, so you explained about program global area, which is the entry point for any of the requests which is coming to DB, right? And what
Correct.
actually happens in SGA, which is system global area?
Yeah, we will come to that. Right. That's a
Okay.
very important area. Okay, compared to PGA. That's where the major operations of your DB will happen. That's what we will see next. What's an SGA? Okay. Okay. So once you download VirtualBox, just search for VirtualBox. Click on downloads, and download it for the Windows host. Okay, just click on it. Maybe I'll copy the link and put it in the chat. Okay. Once you install VirtualBox, next what I will be doing is I will be giving an image to all of you. Okay, VirtualBox image. What you need to do is, this is the image. Just you need to double click. It will automatically open in your VirtualBox. Okay, this dialog box will open. Okay, you don't need to do anything. Keep everything same. Okay, don't change anything. Just click finish. So it will import your VM, okay, into VirtualBox. So wait for it to get imported. Okay, till this is getting imported, let's see on SGA side. Okay,
Server also, there is a virtual box.
what Aditya? Can you repeat?
For SQL Server also, we will do the same, or there is another way, because we need to see SQL Server also, right?
Yes, yes. So this is for Oracle. For MySQL, we have on the MySQL workbench.
Okay.
That will be on your local machine itself. We will set it up. And Aditya, so no need to worry. Okay, most of the things what you will learn in this Oracle, right? It will is actually very much related to MySQL also. They share a lot of things. Okay. Okay, so let's come to now SGAs. Okay, so SGAs are generally called System Global Area, or even some people call it Shared Global Area. So just let's stick with System Global Area. Okay, so what the System Global Area is for is, now inside the System Global Area, you have multiple other components. So inside System Global Area, you have the library cache, your data dictionary cache, your result cache, which is called the shared pool altogether. Then you have something called a data buffer, database buffer cache. Okay. Then you have the large pool. Then there are some Java pool, streams pool, which we will see what it is. Now inside this SGA, so basically, see, whenever a query is executed, okay, what will happen is that execution plan or whatever plan is created, okay, that will be stored in your shared pool for a reuse purpose. Okay, so for example, now I executed a query, so first time it executed from the disk. Okay, now what will happen is when it's executed from the disk, first of all, it will be stored in your database buffer cache. Whatever the result is there, right? That will get stored in your database buffer cache, the data, real data, right? Now, what is getting stored in the library cache? What is getting stored in data dictionary cache? What is getting stored in the result cache, right? So that we need to understand. So in your data dictionary cache, okay, all the database objects and permissions is stored. So now what are these database objects? So similar to your Java program or any other coding language, right? Even DBs also have objects. Are you all are you all aware about that? Like objects are created for DBs also,
Yes.
right? So those objects are stored in the data dictionary cache. Okay, now in the result cache, okay, what it will store is it will store the result of some commonly used queries. Like for example, like let's say there is some query which is being called like 100 times and other queries are called only 5 times. Okay, so now this query, this is which is being called for 100 times, now Oracle knows this is getting reused, like there is no change at all. Like let's say I am reading some URL. Okay, so unless I don't change the URL, that URL will remain same, okay, inside the DB. So what Oracle will do is this result cache or this area, the shared pool, is faster than the buffer cache. Okay, so the shared pool which you have here, this small area here, the shared pool is actually faster than the database buffer cache. Okay, so what it will do is Oracle, it will store that in the result cache rather than putting in the buffer cache, because the buffer cache is little bigger cache area compared to shared pool and all, and there will be lot of other data in buffer cache, but in result cache only very high level, those data which is called in very high numbers repetitively, right? Only those data will be stored in the result cache, other data will be stored in the buffer cache. Okay, now, when it comes to even the result of some functions or some commonly used queries, those will be stored in the result cache. Now, library cache is very important cache. Okay, so it will store your execution plan, it will store your procedures, packages, some control structures and all inside your library cache. Now, execution plans play a vital role. So all of you get that point, like when we discuss execution plan, right? So what is an execution plan? Anyone? Okay, anyways, we will see that in reality. So that time it will be more clear. But
It shows
execution
the
plan is simple. The plan in which your DB is planning to execute a query, right? So what's the order and how it is going to execute that query. So that is the execution plan. Actually, Oracle will store this execution plan inside your library cache after the first time. So second time, third time, when that query comes, it already has that execution plan. It will just execute. It will not calculate. So that time required for calculation of that execution plan and that overheads will not be there from the second, third, fourth time, right? So that's why it is stored in the library cache. Now, based on the bottleneck, can I say, like for example, what I observe is due to some reason my library cache is full, or like the library cache is not getting cleared, okay, or it's totally out of resource. What problem my DB will face? Will it be able to store the execution plan if my library cache is full?
No.
Now, if it is not able to store the execution plan, what type of parse will happen more?
Parse.
Hard parses, right? So disk reads will increase, even like the time for execution will increase because it is not able to store the execution plan. So it will again calculate every time when that query comes, it will try to calculate what's the execution plan, which is a perfect one, right? And it will try to increase the like it automatically your performance overhead will increase, right? So that's why this architecture understanding is very important, right? What each of them stores. Now, when you see the report, in that you will see library cache, you will see result cache, you will see dictionary cache, you will see all these things. But if you don't know what these things are, you will feel, oh, what is the use in looking to this data, right? The percentage is what I'm getting. Because ultimately, I don't know what these things are and what they are storing and what the repercussions will be due to these uh, uh, overheads, right? So now, for example, again, the shared pool size in overall, right? If you see the shared pool size, like the library cache, data dictionary, result cache, all together we call the shared pool, right? The shared pool actually size a shortage will lead to a lot of issues, okay? Especially as I said, a lot of hard parses and all. Then also the buffer cache. Now, what this buffer cache stores, it copies, what it stores is copies of data blocks, right? Whichever is read. So just assume like it got some 100 employees data, right? When a query was executed, it will store that data in the buffer cache. Now, but very important thing to understand about buffer cache is, now I stored 100 data, okay? Again 100 is coming, 100 is coming, 100 is coming from various other sources. So those data it is storing. Now, when your buffer cache is full, what do you think it will do? Will it clear the older data and write with the new data? Will it do that? You're
Ideally
getting my
should do
point,
that.
right? Like let's say my buffer cache is full. Okay. Now new data is coming, which it has to write. So will it clear the old data and write the new one? That it will do, right? That's the most
All
logical. Yeah, Dev, go ahead.
No, sorry, I was just continuing on the same. That probably there will
Yeah,
be
right.
some algorithm where least
Correct.
connect, least used data might be deleted or something of that sort.
Exactly, exactly. Right. So similar to garbage collections, right, which happened, or the garbage clearance. So what it will do is it will look for a data which was used, least used, and which is very old, right? So those that way it will try to clear the data. But the problem again with the buffer cache is if it is too small, what will happen is lot of IO operations will fail. Okay, because what happens is it will continuously it will get reloaded from the disk. Because your buffer cache is full, so automatically things will get read from the disk, right? Because there's no new space to store it in cache, and every time your queries are asking for new data, so disk reads will again shoot. So ultimately everything will increase the disk reads if you see fundamentally, and if the disk reads increase, that will create a performance overhead. Okay, even there is something called a log buffer also. What log buffer actually holds is a redo log. Okay, so just assume that okay, what I'm sort of talking about is this redo log. Okay, this disk. So what it redo log buffer, what it does is, now let's say I am making some changes to the DB. Okay, I am deleting Aditya's whole row. Okay, now when I am doing this, what actually the DB will do? No, it will create a copy of the DB and keep it. So if something goes wrong, it will roll it back to that previous version so that I can redo it. Or there is something called an undo data also, which we will see what it is. But for now, just assume redo log buffer is nothing but If you want to erase that change or roll back something, right? That data is stored in the redo log or the redo disk or the redo log buffer, right? Again, here also the problem comes. If your size is slow, redo log buffers actually cause bottlenecks, okay? And because it cannot store that amount of log files, and which will lead to frequent flushes and all, which we will see, okay? Yeah, anyways, so let's come back to our system now. So is it clear about SGA? So what's an SGA? What it does? Any doubts related to SGA?
You are going to cover the other parts also, right? Like this, what is this Java pool and streams pools?
Yeah, so they are like
Pool?
a we can say they are like a interface for various languages. Okay, so what this Java pool and this streams pool do is, now let's say if you are working on some Java based applications or it's a memory area which is dedicated to storing Java code and even data. Okay, so if any Java based applications you are running, it will store that Java procedures and all. So it will store that Java code inside that. That is Java pool, specifically for Java related programs. Okay, maybe because what we see is most of the applications which we see, they are Java based, right? Like on our server online and also that's why Oracle would have thought that Java pool component is good to improve the performance. Okay. Similarly, there is something called streams pool also. What streams pool does is it is used for exclusively by Oracle to memory capture and some applying some process, more sort of to apply something to your DB, right? You use streams pool to some configuration you need to update and all, right? You can use streams pool. Similarly, IO buffer, free memory response, this large pool is not that important for you to know because as per performance is concerned, we generally don't have much control over this. But there also you can do some things like, for example, what is the session memory, some IO server process, parallel executions and all which happen. Uh, Again, but you just need to see your large pool is not without memory, right? If you have enough memory, it will have resources to concurrently process various threads. Yeah. Okay. Any of these components, anyone has any doubt? I will go through that once more. Let's start from PGA. PGA, any doubts?
Yeah, hi Vishnu.
Yeah, go ahead. You had some question.
No, actually I joined. Could you please brief over this? Just that will be helpful for me.
Your voice is breaking, Shensha.
Are you able to hear me now?
Yeah, because it feels like you are in
Clear now.
a very rainy area.
Yeah,
Sort of
that's
that
what
noise,
actually I was
that
in
white
rainy area.
noise. Yeah,
Yeah.
Chenja.
Could you please repeat this? Could you please repeat?
Okay,
I'm
okay,
not sure
yeah.
that.
So see, we are almost in a little deep into that, but anyways, so see, to give you a high level overview, in Oracle architecture, if you see, you can divide that architecture into PGA, SGA, disk, and the redo log disk. Okay, so inside PGA, what it will do is it will have session level details. Okay, for example, there are like 100 users, 100 areas, private SQL areas will be allocated. So that's what you're seeing here, the private SQL area, right? What you're seeing here, this private SQL area, for each user it will be allocated. Okay, so if your PGA resource if it's not enough or if it runs out of storage or memory, higher amount of disk reads directly will happen. And also your sort operations, some operations like hash join, bitmap merge, and those operations will fail. Okay, so your PGA size, how much memory that PGA has is very important. Okay, similarly, inside SGA, now once that sorting and other things are happened inside PGA, it will enter into SGA. Okay, and it will store for example, the execution plan which has been derived, right? It will try to store it in the library cache. In the data dictionary cache, it will try to store the objects and all. In the result cache, it will store the result of those queries for which those queries for which is being called very frequently. Only those results of those queries will be stored in result cache. Now, buffer cache and result cache you can easily confuse, okay, because both are storing data. But result cache is, you can say, like there is some query which is called 100 times and there is some query which is called 10 times. The 10 times one will be stored in the buffer cache, 100 times one will be stored in the result cache. Okay, so result cache is faster than buffer cache but smaller in size, like in the MB size. Okay, it will be smaller. Okay, now buffer cache is storing the data because, like, let's see, every time when I'm executing a query, I don't need to pull the data from the disk. I don't need to give overload on the disk, right? So that's why what we do is we store it in the buffer cache and we read it from there. Now, in case if there is any change in that query or a new query is called, that time it will go to the disk. And when it goes to the disk, again it will get stored in the buffer cache and then delivered to PGA back. So every time this buffer cache reading and writing will happen. If any change, or we call it data manipulation, if something happens, right, this the buffer cache changes. Okay, similarly redo log buffer is there, which is for storing all the logs and all, so that if you need some rollback and all, you can pick up the data from there, right? So this is how the overall architecture of Oracle looks like. So any doubts in that, anyone?
One quick question, Vishnu, that
Yeah.
what will be the size of this redo log buffer and the database buffer cache? Because there has to be, it cannot be more, it cannot be less also, right? So what is in general the default sizing and what is the recommended sizing that
Mhm.
you generally keep for this caching or the
Yeah.
buffers?
So see, this redo log buffer size and the buffer cache size, we cannot have a rule of thumb as such, because it changes with respect to how much amount of data you are storing, how much sharded DBs you have. Okay. So when I say sharded DB, it's more sort of like a concept where you have multiple DB servers. Okay. All more sort of like a separate, right? But they all contribute to data processing and all those stuff. So, but to say something on the size, what generally we observe, okay, um, buffer cache buffer cache to redo log. Obviously, buffer cache size will be higher than redo log. It will not be lesser. Okay, uh, but let's say if you have an application like maybe this time as I'm just thinking about the applications which I have worked, like let's say if you have some application which has which will be in the ratio, like for example, so again as I said, we cannot have a standard size. When I'm thinking about some ratio, can we keep it, okay, for redo log to buffer size, but
If
generally.
not ratio, the general
Mhm.
sizing is somewhere mentioned because there might be some
Yeah,
default
so 20
sizing.
to 30 percentage, yeah, so 20 to 30 percentage of your total available memory, right, you can keep it for buffer. Okay. Now, around like, let's say this redo log will be like around 4 to 8 MB only. Are you getting my point? So buffer cache is very big because it's 20 to 30% of your total memory. Like let's say if your memory is like 12 GB, or if it is like 100 GB, right? So around 10 to 20 GB will be buffer cache. But 100 GB is not that much high size, you won't get. It will be like 10 to 12 GB in that range only. Okay. So, but if you see the redo log buffer, it will be like 4 to MB, 4 to 8 MB, 10 MB in that range only. Are you getting the difference?
Yeah.
Right?
But the size
Be-
of the DB will be much more, right? It sometimes it might go into TVs also, no?
Because here it is not storing everything, right? It is storing only that part which you changed. That's the redo log buffer.
No, I'm not talking about the buffer. I'm talking about the
Ah.
data, actual data, because you said around 10-20% of the total
Okay, okay,
data
yeah,
would.
got it, got it. So see, now let's say if you have 1 TB data, Obviously, yes, your buffer cache has to be higher, right? 10 to 20% of that, because that much obviously you will be reading and storing. If your 120, 1 TB data is there, I'm saying, okay, data DB.
Got it. Got it. Okay. Thanks.
Yeah. Let's see what's happening with our machine. Okay, so let's start this machine now. Import is complete, so just click on start here. See, whatever I'm taking now, we will be going in depth again. Okay, few things. This is just for the demo purpose. I am just running over few things, but we will go in very much detail. Okay, in the live sessions.
And this VM box, we can install it in Mac as well.
Yes, you. What you will have to do it. You need to download it from here. Let me see if it's available for Mac. That's a good question. And yeah, so here from Mac OS, right? You download this and install it.
Got it. Okay.
Yeah. It will take some time for the booting and all. So let's wait 1 or 2 minutes. Okay, let's continue till that little bit more on the architecture side. Okay. See, now the buffer cache is, as I said, 20 to 30 percentage of your disk or the memory size is SGA, right? So it's the largest memory area of SGA. So buffer cache is generally, you see, it will almost be 20 to 30% of your total SGA size, right? So it's the largest one out of other components what is there, right? And it stores again that data block copies. It reads from the disk, and it is maintained using a complex algorithm, means like cleaning and all, right, which happens it's through that. Then database write process from the disk, or whatever operations happens on the disk is also all goes through this buffer cache. Now if your buffer cache due to some reason is not running properly, or or there is some issue in that cache, okay, will the disk reads happen properly? Because if you see the diagram, disk read is also just passing through buffer cache. It's not happening separately. So if your buffer cache is a bottleneck, will your disk reads happen properly?
No, it will impact. It will get
Yes, it will
impacted.
impact, right? So that's why the buffer cache, generally, if you see, whenever we start our analysis, there is a section where we analyze the table buffer or the buffer cache, which is a very important thing in our report. Okay, like when we analyze, we have something called a shared cursor area or a shared cursor analysis, where uh, we look for the disk reads and all. And buffer cache is clearly like how the buffer cache is performing, how the memory is getting allocated, deallocated, is there any problem in that? Those things we analyze. Okay, similar to heap, right? In JVMs we have heaps, right, where we take the heap dumps and all. We see how the heaps are getting, the garbage collection is happening properly or not. Similarly, in DBs also we need to look for this cache, like wherever the cache cleaning and those things should happen, it should happen properly and should be steady as much as possible, right? Okay, so let's see the, yeah, it's almost done, I guess. Okay, so we will just log in. All these things I will give it to you, okay, later on. This image, everything I will share through Google Drive. Even the materials, whichever I am taking in the sessions, right? All these materials you will get like let me show you. So all this course slides, modules, text, and everything you will get. Okay, so basically these modules itself will have a lot of things where you can actually like using this because there are a lot of things in the PPTs itself which you can use to investigate, report, and a lot of things. Even like various tables I would have created, some like a checklist sort of thing which will be useful for you, right? So all these materials will be useful, and also I'll give you more things based on different queries or different bottlenecks that you observe, a table sort of thing. Okay, comparison and what where you need to look into as soon as you start. Like let's say you got an activity where you need to perform, like you need to analyze. So how you go ahead with it, right? Which all what steps you follow so that you can pinpoint the bottleneck, right? So those things we will see. Yeah, so our virtual machine is running now. Just open this SQL developer. So data, everything is already loaded here. Okay, so you don't need to worry about that. Already, whatever data we require. So here I have loaded some sales, some HR data and all, which we'll be using for the analysis purpose.
So one very basic question, Vishnu,
Yeah.
which I had, might be a very dumb one, but still,
No, no,
like,
that's totally fine. Yeah. Hmm.
so what is actually the difference between the Oracle, versus this MySQL thing? Because eventually Oracle also uses a kind of query which is SQL query only, right? So there
Right.
is not much
Hmm.
of a difference.
Hmm.
Then what is
Yeah.
the difference between the two? One is open source, and even MySQL is not open source, right? Like
Hmm.
how are they different from each other?
That's a very good question. So, see, the main difference which you will be easily able to observe in the Oracle is actually Oracle is far more optimized than MySQL. Okay, now this is very controversial because why I say this is um, easily by just checking it for just small level of data, you won't find this discrepancy. Okay, but you will find that easily when the data size is very high, like millions of records and all. That time Oracle clearly comes into picture and it wins. Okay, otherwise if you see MySQL Oracle, more sort of like you can compare it like a Jmeter LoadRunner sort, right?
Mm.
Jmeter actually works well if you can use it for a good amount of testing. But when it comes to LoadRunner, when your applications are very sophisticated or the number of users which you're testing is very high and you need better reporting and all, right? We go for LoadRunner, right? So same thing. There. I hope I'm able to.
And MySQL,
Yeah.
do they have any enterprise kind of an edition, like paid version and community edition, or everything is completely free?
No, MySQL is actually created by an open source community, right? So that's why they don't have any paid one. So, but enterprise edition is there, but I'm not sure like whether it's paid because I haven't used it. But what I meant to say is MySQL is totally free only. Yes.
Okay. Okay.
Yeah. And it actually powers a lot of things. Okay, but that is there. MySQL community is far more bigger than Oracle if you see in a high level way because of its open source nature and all, right? So okay, so this is our DB. So for example, like let's say if I want to,
Vishnu, I have Narasimha, I have a question, one more question.
yeah, go ahead.
Vishnu, are you going to cover the Azure SQL also in this one?
No, no, no. That won't be in scope because we have Oracle, MySQL, which we are covering, and we will go through a high-level overview of DynamoDB and all those different aspects of DBs what we have currently in the market. But obviously, tuning in depth, we won't be going. But I'll give you a high-level overview. Okay, what it is and all.
Okay.
Yeah. Because ultimately things, see, they all break down to, most of the things are very common. Okay, so you can easily make out those common factors between each of these. Okay, so let's. So now what I will do is I will just show you very quickly, okay, how we like what's an execution plan actually. Okay, so and how it looks and what's the
The screen
key.
is not shared, I guess.
Is it clear being shared now? Visible item now?
Yes.
Yeah. So this is a basic a basic query. Okay, a query statement. I'm just shifting to SHD DB. So there are three connections to the DB. Okay, HR, SH, and system. So based on the query we run, we need to change the DB connection what we are using. So now I will just run this query. Okay. So this is the data which I got. Now here what I'm doing is I am just selecting star from sales table. Okay, customer ID, and I'm looking for those with the customer ID. One is 987. Okay, and I'm fetching those data from here, right? So around yeah. So now what we will do here is, now this thing Oracle executed, okay, it got the data, it gave me the data. But how did it do that? So for that we have something called the execution plan. Even auto trace also I will explain how to do that. Now this execution plan or the explain plan which we have, right, is basically, it's not getting captured when the Oracle is executing that query. So uh, it's basically, it's just a plan, right? We don't know whether Oracle will really use it or not. But you can trace the execution plan when your query is getting executed, and that's through execution plan and the auto trace. These two methods. Now explain plan, which I did now, right? Explain plan is something where it's more sort of like we cannot say whether this is the plan Oracle will really use when it is executing, but it is just like more sort of like a what I can say, a draft plan, right? Most probably Oracle will use this, but in real execution time, what Oracle will use, that whether it will use this or not, that to make sure, we need to use auto trace, which is basically what it will do is I will start the auto trace, I will hit the query, so that query will get executed, and that when it is getting executed, that plan will be monitored, or I can say it will be captured, and that plan is called execution plan. So that's the difference between explain plan and execution plan. This one, what you're seeing is the explain plan. Are you getting difference between explain plan, execution plan? Uh, or am I confusing somewhere?
Vishnu, can you repeat that one? I did not got it.
You've
Yeah.
missed the
Okay.
point. Yeah.
So there are two things. Okay. One is explain plan and one is the execution plan. Let me open the whiteboard.
Did you mean explain plan is the way it got executed, and the other one is just the plan which Oracle might choose to go ahead with?
That is correct. But explain plan is the Oracle, explain plan is the one which Oracle didn't execute. Execution plan is the one really Oracle executed. So explain plan is more sort of like a initial entry point. Okay, it has a probability, like 80% probability that it will use that explain plan. But execution plan is a real one which Oracle will execute. I mean, like has executed, right? Now to explain you, so see, whenever like let's say there is some process, okay, it runs, and this process will trigger a query in the background. Okay. And when this trigger happens, okay. Now when this happens, obviously Oracle will use an execution plan to execute it, and you will get the result. Okay. Now this whole process is happening in real. Okay. It's happening in real. I don't know why my it's getting stuck. Okay. So this is happening in real. Now what I did now, generating the explain plan. Did I trigger a job, like a process? Did I trigger a process, or I just ran a query? What did I do?
Run a query.
Yeah, so just I ran a query. It's more sort of like I executed a query in Oracle SQL Developer. It's not getting executed. It's just I ran it and I got the explain plan. But when your process runs, this complete flow is not there in this second method. What I did, only I am triggering the query. That's all. Only that one step is there, right? So due to this, what will happen when this real execution is happening, right? This execution plan might be different from this. This explain plan and execution plan might be different. So to solve this, only what I do, obviously explain plan will give me a high level overview what is happening. But to get that real execution plan, I need to start a trace. So when I start a trace, then I run the process, whichever will trigger that query, maybe in the front end or back end, wherever. Okay. Then once the result, I get the result, I will stop the trace. Now whatever execution plan I get from this trace capture is the real plan, and real plan is called the execution plan. Explain plan is just the dummy plan which Oracle is planning to do. Is it clear now?
Yes.
Right? So this is very important. Okay, many people confuse with this when they say explain plan and execution plan. These two things are really very much different. Okay, but for a high level way, when you're analyzing, you can easily go with explain plan for the initial analysis, because 80% of time that will be the plan which Oracle will use. Okay, but execution plan is the one which is actually what is happening. Okay, which the Oracle is using. Okay, so yeah, any questions or any doubts, anyone? So this is the explain plan which got generated. This is how it looks. Okay. You can also go to, I don't know, I will increase the size of my RAM. Okay. Because it's very slow. I mean like the RAM of the virtual box. Okay. Yeah. Any questions, anyone? And what these object name options, what is this cost, what are predicates, what are these things, and all those and how to read this execution plan basically. Okay, and find out which one is causing issue, and which is the area where we can look into more and fix it, right? Those things we will see in the upcoming sessions. Any doubts? Or else we can stop it here for today, and we'll continue tomorrow. Yeah, thank you all. Have a good day.
Vishnu, one quick
Yeah, Dev.
question. Like in this
Yeah.
session, like how many sessions or number of hours you're actually planning to take for this
Yeah, it
course?
will be around 20 hours, means 20 sessions around. Yeah, but based on the interactions, it might go a little higher. But if interactions are low with the audience, yeah, it will be done within 20 sessions.
Got it. And the sessions will be on Monday to Friday, is it?
Correct. Yeah, Saturday, Sunday will be off.
Thank you
And
so
the
much,
regular
Vishnu.
session will start when, like from tomorrow or
Mostly,
Monday?
I think tomorrow because it's almost 2 days now, right? I don't know. Generally, they plan it. I don't interfere in that. So maybe tomorrow you will get a notification in the WhatsApp chat, I think.
Okay.
Yeah. Mostly we are done with the demo. I meant like a demo is almost done. We have started the sessions all already, right? So you can consider that our sessions have started. Yeah. Okay. Thank you all, and have a good night and good day. Thank you.
Thank you so much, Vishnu. Good night.
Yeah.
Take care.